Welcome back. Let's dive deeper into regular expressions in Python. Remember, we must import the regular expression module. That is the standard RE module. It comes built in, with no installation needed. It's ready to go. Now, let's look at our target strings. We want to scan the text and isolate a very specific pattern, the prefix INV-4668. Check out how patterns work. The ultimate power of Regex is matching precise patterns. Notice how the second pattern here looks almost identical to the first. But notice the letter A right before the digits in that first line. Our goal is to extract the exact phrase INV- followed by digits. If this syntax looks a bit strange, don't worry. That letter R tells Python to treat this as a raw string. Very common everywhere. It ensures Python reads every symbol literally. Inside our search function, we pass the pattern with INV- enclosed in parentheses. This creates a powerful feature called a capture group. It isolates parts of our text. By using groups, Python will automatically extract the INV- prefix and separate it into its own distinct section. It saves this cleanly behind the scenes. This cleanly breaks up your text data effortlessly, meaning you never have to deal with messy string splitting again. It is the ultimate shortcut for data extraction. Now, our second group captures the numbers. We use \d to target a sequence of digits. Perfect! It grabs every consecutive digit until a non-digit appears. So it captures 4668 and stops right there. Why? Because the next character is a non-digit new line break. A fresh new line. Watch closely when we execute this code. Group 0 always yields the entire match. Everything matched by your pattern is there. Then, look at group 1. That represents our very first parentheses group. It found and cleanly returned the INV- prefix. Next up are the digits. Let's inspect group 2. It holds the digits 4668. But wait, why did the search stop right there? Why didn't it match the other invoice sequence below it? Here's why. It found a match. The moment search finds its very first match, it stops completely. That is why it skipped the rest. Watch what happens if we remove that leading letter A from the string. Instantly, it detects the pattern on the very first line. Because that is now the earliest valid match available, it captures it and ends the execution. That is the core power of search. It locates the first match and halts. From there, you can instantly pull out your captured groups. Exactly. Just use this syntax. Your match object followed by .group, passing the index number. Remember, index 0 always holds the entire match. Smash that like button, subscribe for more tips, and leave a comment below to support the channel. Last time, we mastered Python's regular expression search function. It's incredibly straightforward. Just import the built-in re module. No pip install required. It's built right into Python. Now, let's look at our target pattern. Imagine we want to extract a specific string, like this invoice code INV-566. When the search function runs, it scans for that exact pattern. Notice we're targeting INV followed by a dash. By using round parentheses, we can isolate the individual components of our search. We capture the prefix, the dash, and the number 5666. This cleanly separates the prefix from the numeric ID, which is perfect if you need to query a database. No need for clunky, manual string splitting routines. Python handles the heavy lifting automatically. All thanks to those capture groups. Those parentheses define our capture groups. Python will match the entire pattern, then slice it up. It extracts the prefix section, pulling out INV completely on its own. This eliminates manual parsing because you explicitly marked the text and the numeric digit groups. It identifies the digits and isolates them. That's why group 0 holds your full match. Everything, including the letters and numbers, lands right inside group 0 automatically. That's where it's stored. Group 1 captures the prefix, and group 2 holds 5666. There's your raw ID. Now, you can instantly pass group 2 straight into a database query to find a specific record. No manual cleanup required. Parentheses do it all behind the scenes. That is a massive time saver. Now, let's look at search versus find all. As you saw, the search function only returns the very first match. It only found 5666. It completely skipped subsequent entries. It missed the others, but find all harvests every single match. Using the exact same input text, we import the regular expression module, but execute the find all function instead. Notice the setup here is identical. We're targeting the same pattern structure. The underlying logic hasn't changed, but watch this. When executed, it returns a native Python list. Those square brackets prove we've got a list. Inside, look at what we got. Our first code, 5666. Check it out. Findall returns a list of tuples for your groups. Instead of match objects, you get clean raw tuples. It instantly splits the prefix from 5666. The core difference, it skips the group 0 full match, while search gave you the entire matched string up front. Findall targets exactly the specific groups you defined. It sweeps through the text, pulling every single matching code and ID. This provides an incredibly efficient way to batch process data, pipeline it straight to a database, or reformat it instantly. And there you have it, a lightning-fast breakdown of Findall. Remember, Findall harvests every single match in your text, while search stops at the very first one. Plus, you get clean list outputs instead of wrestling with match objects and individual group index lookup. It's that simple. Happy coding. Let's master Regex, focusing on the powerful search function. We import this search tool directly from Python's built-in regular expression module. Best of all, Regex comes pre-installed with Python. There's absolutely no need to pip install anything. Imagine you are analyzing a large batch of log data, and your main goal is to check if an error exists. We scan specifically for the word error. Finding it means there is an issue to fix. To do this, we pass our target keyword as a parameter into the search function. We are searching for error. The prefix R defines it as a raw Python string. While it isn't strictly mandatory, a standard string works perfectly fine here too. The R just ensures Python treats it exactly as written. Next, we supply the target text to search, which is our log data. Once a match is detected by the system, we instantly extract its exact start and end positions. Keep in mind, it ignores duplicate entries and only returns the very first match it finds. This is crucial. It gives us a lightning-fast way to scan any piece of data. If a match appears, you know there is a bug. The start property pinpoints the exact index where that first instance begins. Meanwhile, the end position marks where the matched sequence concludes. Then we have the group method. This explicitly returns the actual text captured. We searched for error, and it successfully found error. The span property returns the coordinates 37 and 42. This arrives as a tuple. Perfect. If we wrap this object inside Python's built-in type function, the output confirms it is indeed a tuple. It explicitly shows a tuple containing two distinct integers. So the group method simply extracts the string we targeted. Now, what happens if we search for a term that doesn't exist? Right now, our active search is successfully finding a match. The span is 37 to 42, and the verified match is the word error. But if we look for something like error 1, everything changes. By being specific with error 1, the system reacts differently. The function now evaluates directly to none. This is Python's equivalent to a null value. No match was discovered, returning none. Trying to query properties now triggers an attribute error. The start attribute doesn't exist on a none value because absolutely no match was found. And that is the search function in a nutshell. Use it to scan massive datasets instantly for target keywords, allowing you to trigger next step actions seamlessly. Let's master Python's powerful regex split function. First, import the regular expression module. It comes standard with Python. No pip install needed. Imagine you are a database admin, and your system logs look like this. Let's examine the layout. We have error, a pipe delimiter with spaces, and database. Offline, followed by another pipe and a timestamp. Our goal is to cleanly parse this log. Let's run the split function to see how it works. We want to isolate our target pattern, a space, followed by a literal pipe character, and another space. That sequence acts as our separator. That's the core logic of regex split. Now pass in the target text. The elements are stored beautifully inside a list. Let's look. Running this gives us our clean list. Notice the square brackets? That confirms it's a list. We have our error string right here, the database offline message, and the date. 3 completely separate parts. But what if you only want to extract the first part? Python makes this incredibly simple to do. Look at this section. We search for a colon separator. By passing the number 1, we limit it to 2 groups. This isolates the first segment completely, leaving the rest of the string untouched. It executes exactly 1 split. Now you can easily flag high-priority errors and handle them with custom logic. And there you go, an essential regex tool for your Python toolkit. It's highly efficient and easy to implement. Remember, \s matches a space surrounding the pipe. What happens if we omit the trailing space? Let's see. If you leave it out, that extra white space is kept inside your parsed dataset because it is no longer treated as part of the separator. Python's regular expression split function is incredibly powerful for parsing data. Look at this example string containing Python, Regex, API, and backend. Notice how the separators change every single time. First, we have a comma, then a semicolon, and finally a pipe character. Since these delimiters are completely different, we need a clean way to handle them all. Our goal is to cleanly isolate each word into separate parts. We want to extract Python, Regex, API, and backend. So how do we do this? We use the split function. Remember, the regular expression module comes standard in Python, so there's no need to pip install it. Simply import it directly. Just import the RE module and call it split method, passing in the target data you want to separate. For the pattern, notice that we are using square brackets. These brackets create a character class. Perfect! This tells Python to split whenever it encounters a comma, a semicolon, or a pipe character. By doing this, your text gets divided beautifully. Let's see what happens if we don't use this syntax properly. If you leave out the square brackets, watch what happens next. The split fails to catch everything, which breaks our output. To fix this, you absolutely need to wrap these delimiters inside square brackets. Run the code now, and boom, you get the exact output you want. Now, if you only specify a single comma, look closely at the result. It splits at the comma, but leaves the rest completely untouched. So you think, let's just add a semicolon, but check out what Python does here. It searches for the exact sequence, which fails completely. By utilizing square brackets, you instruct the engine to look for either a comma or a semicolon independently. But remember, the pipe character is still missing. Let's add the pipe inside the brackets. Now that it's included, the string splits flawlessly. Just like that. A quick, elegant solution to add to your Python toolkit. If you found this breakdown valuable, hit like and subscribe. Drop a comment below to help others master Python. Want to hide customer IDs from your data? Python and regular expressions make it incredibly easy. Here's how. First, we import Python's built-in remodule. It comes completely standard, so no extra installation is needed. Let's look at an example. Imagine receiving this support ticket text. It contains a sensitive customer ID, specifically customer ID 874561, followed by a refund request. Before processing this text, we need to completely mask that identification number. If you are feeding data into an external AI model, protecting user privacy is absolutely paramount. Exposing private customer data to outside networks is a major security risk you must always avoid. To solve this, we use the sub-function from the remodule. We want to search for a specific pattern, \d, which targets numerical digits, capturing every single consecutive digit in the ID. Adding a plus sign ensures we capture the entire sequence. Next, we provide our replacement string, swapping out the actual numbers with the word hidden. Finally, we pass in our source data. Run the code and look at this clean output. The customer ID is now hidden seamlessly. Perfect and secure. Your sensitive user data is now fully protected. Data obfuscation and redaction is a breeze with Python Regex. But what happens if you forget to include that plus sign? You will get the word hidden repeated for every single digit. Without the plus, Python treats each digit individually instead of grouping them into a single continuous sequence. That plus sign means match one or more digits as a whole. Also, remember that / without it, Python will just literally search for the letter D instead of a number. So always use \d to tell Python you are targeting a full sequence of numeric characters. If you found this useful, smash that like button, subscribe, and follow for more elite Python tips. How do you quickly clean up extra spaces in a Python string using regex? It's incredibly simple. Let's dive right in. First, import the regular expression module. It's designated as RE, and once imported, you don't even need to pip install it. It comes standard with Python. Just import it and you're ready. Take a look at this messy target text. We want to collapse all these gaps into single spaces. By utilizing the sub-function within Python's regex module, we can instantly achieve a clean, polished output. See how perfectly it formats? Here is how it works. The prefix letter R denotes a raw string. This highlighted pattern tells Python to read it exactly as written. Inside the pattern, the \s expression specifically targets any whitespace character, while the plus sign means one or more of them. This indicates a single space. See the dot right there? It stands for one single space. So we capture any sequence of consecutive spaces and condense them down. Watch it happen right here. One clean space left. What happens if we omit that plus sign? Python will evaluate every individual space independently. You'd essentially get the same exact string back because each space just replaces itself. But the plus sign commands Python to look for a sequence. It groups every contiguous space until it hits a non-space character. It locks onto the first space, rolls through the next one, and keeps accumulating them into a single block. It scans forward until it strikes the letter S. Recognizing it's a character, it halts, it stops, and instantly replaces that entire chunk with a single space, all thanks to that plus sign. Let's run it and watch the magic happen. Now, what if we accidentally omit the \? Notice how it shifts. It starts targeting the literal letter S instead of whitespace. Replaced. Look at that. James completely lost his S. That completely breaks our code, which is not what we wanted. If you just search for a standalone S, it yields a similar issue. It targets the very first S it finds and swaps it out right there, leaving the string completely altered. But wait, why did it skip the other letters? Because those are uppercase. Regex is case sensitive by default. Let's change it to uppercase. Now, look at how the entire string gets disrupted. Smith suddenly becomes myth, and sales turns into ales. Definitely not the result we wanted. So always remember the golden rule. Use \s followed by a plus sign. Execute that, and it works like absolute magic. Regular expressions are incredibly easy to master and ultra powerful. You won't need any other data cleaning tool. Loved this trick? Hit subscribe and like for more. Python includes built-in support for regular expressions. This standard module is automatically available. No installation needed. Just import it directly. Now see the magic happen. Imagine you have a date string, formatted like 2026/06/21. Our goal is to find every forward slash and replace it with a clean dash. To achieve this clean output, let's break down the syntax. First, call the regular expression module. Then, access the sub function. Perfect. By adding a dot right here, the sub function becomes available. Next, we supply the arguments. The letter R denotes a raw string. Yes, it is completely optional here. You can leave it out. Without using the R, we define the target / and swap it out for a neat dash. So simple. Finally, pass in the target variable that holds the text. Works flawlessly. But what if you only want to replace the very first slash? Easy fix. Just add a comma and look at the optional parameters. See, it specifies a count. The count. How many replacements? In this scenario, we only want to change one. Execute that, and notice the output dynamically updates. It swaps the first slash right after 2026, while keeping the remaining / perfectly intact. Set it to 2, and instantly both slashes are replaced. What if we pass 3? Any guesses? Will it crash? Not at all. It runs smoothly. Even using 99 works perfectly. But watch what happens if you pass 0, as you might expect. Nothing changes because 0 triggers a full replacement. That's right, the default value is 0. It modifies everything unless specified otherwise, so this parameter is optional. It defaults to 0 as a clean integer. Run it, and there's your result. But pass 1, and it precisely replaces just the first instance. Now you know how to rapidly normalize and transform text data using powerful regular expressions. Boom! You are officially a regex master. If you loved this shortcut, smash that like button, comment, and subscribe to support the channel and unlock more elite Python tricks. Welcome to a game-changing feature of Python's regular expressions. You definitely don't want to miss this powerful technique. First, let's import the re module. No pip install needed here. It comes built right into Python. Imagine you have this raw text string right here, and we want to reformat INV-4821 into invoice 4821. How do we achieve this? By using the subfunction. Watch. This function from the regular expression library allows us to substitute specific text patterns. The best part, it can preserve parts of your text while effortlessly replacing the rest. Let's set up our target replacement. Pay close attention here. This is no ordinary replace. We want to target INV- followed by any dynamic number. Exactly. No matter what that digit sequence is, we will swap INV for invoice and extract the numeric values dynamically. Right now it is 4821, but it could be any sequence in the future. We will add a clean space and seamlessly output that extracted number. Behind the scenes, executing this command leverages a concept called capturing groups. Let me show you how this works. By utilizing group 1, we tell Python to inject our captured digits. Our pattern uses a \d to match any digit continuously until it encounters a non-digit character, like the end of the line. Once it hits that boundary, it stops and isolates those numbers. Now you can construct clean strings, combining the word invoice with that captured group. Wrapping your pattern in parentheses is known as grouping in Regex. Let's create another group. We can even isolate the inv prefix into its own group to see it in action. Just by adding parentheses, a brand new group is instantly created. Look at position 1. It targets inv- perfectly because that is what we defined. That is exactly what the pattern is looking for. It finds that text. Now, our original digits group shifts over into position 2. And there it is, 4821. But watch what happens if I remove that first set of parentheses. Only one group remains, so if you try to reference group 2, Python throws an error. It cannot find a second group, because only group 1 exists. Think of it just like math equations, where you isolate operations inside standard parentheses. So we'll stick with group 1, run the code, and get this beautifully formatted output. We replaced the prefix, kept the essential digits, introduced new descriptive text, and seamlessly stitched our captured numbers right back into place. It is as simple as that.